right, so I want to talk a little bit about the oxidation of luminol, sometimes called the firefly reaction, where you perform a chemical reaction and that chemical reaction results in the evolution of light. The reagents that we use for this are luminol and basically luminol and then hydrogen peroxide. And the hydrogen peroxide plays the part of the oxidizing agent where it oxidizes the luminol. And when the luminol is oxidized, the product that ends up from that reaction, or the final product or the intermediate product of that chemical reaction, some of the electrons aren't in the place that they normally would like to be. And the place where electrons normally would want to be in an atom or in a molecule is what we call a ground state. And the electrons in luminol following the oxidation by peroxide are in what we call the excited state, which means they have more energy than what they normally would like to have. So those electrons will come back to the ground state, and when they do, they release that extra energy, in this case, in the form of light. Now, some reactions is in the form of heat. We talked about the idea of that being an exothermic reaction. This one is going to give off light. We call it chemiluminescence, chemical reaction that results in light being evolved. And so we're going to take a look at that reaction first. I've got two reagent bottles here. This one has luminol, and then it has some sodium hydroxide in it. Sodium hydroxide to provide the correct pH, the correct level of acidity for the reaction to occur. And you notice that solution is fairly clear. It may have a slight tinge of yellow to it, which is not uncommon whenever you dissolve an organic compound in water. And the other is going to be hydrogen peroxide as well as potassium ferrocyanide. The potassium ferrocyanide is yellow in color, so you'll notice this solution has a yellow tinge to it. And that potassium ferrocyanide is what we call a charge transfer catalyst or a charge transfer agent. It helps to facilitate the movement of electrons back and forth between the hydrogen peroxide and the luminol. And what I'm going to do is I'm going to mix those two things together here in this graduated cylinder. And when we do, you'll see some light that will be evolved by the chemical reaction. And you get a nice, brilliant blue color that results from that luminol oxidation. Now, what I'd like to do is I'd like to do that at a little bit grander scale. It's great to see the blue color, and that's really neat, but I'm going to put it through this tube that we call a condenser, as a coiled tube inside. We use this sometimes in chemical reactions to keep things from evaporating, because what we can do is this tube is cooled, all right, by a jacket of water. We can input water in these two positions, and we normally would use cold water for that, and it would cause the vapor that came from the chemical reaction below to condense and fall back in. Now, the reason you do that is because some chemical reactions you want to perform for hours and hours and hours at a very high temperature, maybe at the boiling temperature of some liquid, of some solvent. And so you want to keep that solvent from all evaporating away, from boiling away. Otherwise, it would all be gone and everything would dry up. So you use that condenser to keep it, that vapor that's produced in the boiling process will be recondensed, it'll fall back down, and you should end up with roughly the same volume that you started with. So when I come back, the lights are going to be out, and I will perform this reaction in this condenser. So remember, our reaction is between luminol and hydrogen peroxide. So I'm going to pour both of those solutions into the funnel at the top of this condenser at the same time. The reaction will occur, we'll see the blue glow, but as that solution, that reaction mixture, is moving down through the tube, you'll see it be transported through this spiral tube, this condenser, until it falls into the round bottom flask, or the Florence flask, I guess is a better term for it, at the bottom, where you'll see the blue glow continue until it's extinguished, until all the reaction has been performed. Okay, here we go. Now to me, that's a really cool way to visualize the chemiluminescence of luminol. I hope you enjoyed this video. Thanks for watching and have a great day.